This geometry video takes a detailed look at the angles formed by a pair of parallel lines and a transversal. We would like to refresh our memories on those two key words. Let us start by drawing a straight line across. A line which is parallel to this one is also drawn out there. Parallel lines always have the same gradient and always the same distance apart. It is common to mark parallel lines with such marks, either a single arrow or a double arrow or sometimes 3 arrows. But whatever mark is used on one line must be the same as on the other line so that we can easily identify the pair of parallel lines. A transversal, on the other hand, cuts right across the pair of parallel lines. We call it the transversal. Now let's get into our lesson and look at the relationship between the various angles formed by this setup. Between a pair of parallel lines and one transversal, there are 8 distinct angles. 1, 2, 3, 4, 5, 6, 7, 8. And please note, this numbering is purely arbitrary. We could have named them in any order. What is important though is their positions with respect to the parallel lines and the transversal and the relationship that they create. And that is the purpose of this video, to identify the relationships. These are called exterior angles because they are outside the space between the parallel lines. 1, 2, 7, 8 are called exterior angles. Then the angles in the space between the parallel lines on either side of each parallel line, these 4 angles, 3, 4, 5, and 6, are known as interior angles. The good thing is that if you pick any 2 of the 8 angles, any 2 whatsoever, there are only 2 types of relationship that is possible between the 2. They are either, mark my words, they are either equal or supplementary. So those 2 words, equal or supplementary, are the only 2 possible relationships between any 2 angles we pick from this setup. The first pair is known as X angles, or vertically opposite angles. We say X angles are always equal, or vertically opposite angles are always equal. And we shall now be demonstrating this by showing the measures of every pair we mention. Here we have X angles. X is as a result of this pattern that is formed between the angles. When 2 lines intersect, the point of intersection is called the vertex. And on either side of the vertex, we have equal angles. This pair, for instance, that is why it is called vertically opposite angles. Sometimes vertical angles, but this vertical comes from the relationship they have across this vertex. Here is the other pair of equal angles across the vertex. So vertically opposite angles are always equal. Below here, we also have another pair of X angles. This is a pair of vertical angles, always equal. The next pair of equal angles we shall note are known as the F angles. When you look below each of the parallel lines, but keep to the same side of the transversal, we have these 2 angles that seem to be under the arms of an F shape. They are called F angles, or corresponding angles. We say F angles or corresponding angles are always equal. And we can flip it around and still get a pair of F angles on the other side. Sometimes it could be inverted like that, and still you can see the F angles, this time above the parallel lines. What's important is not the way the F is placed, but for you to recognize this pattern in any orientation, on the same side of the transversal and on the same side of each parallel line. Z angles are also equal. Z angles, or alternate interior angles, are these 2 angles formed on opposite sides of the transversal, but they are both interior angles. So interior because they are both interior to the parallel lines, and alternate because they are on opposite sides of the transversal. So the shape Z may look sometimes very obvious, sometimes it may be stretched out, but the same relationship holds. Sometimes it may be squished, but the same relationship will always hold. And sometimes Z could appear flipped over, so don't ever miss the shape in whichever orientation. Z angles, also known as alternate angles, are always equal. The last pair of equal angles we shall look at are alternate exterior angles. Alternate means on opposite sides of the transversal. Exterior means both of them are outside the pair of parallel lines. So alternate exterior angles are always equal. So we have that pair, and also we can flip over to the other side and still find this pair of alternate exterior angles, always equal. We shall now look at those pairs of angles which are supplementary. That means the pair adds up to 180 degrees. The first is this pair of C angles, also known as same side interior angles. Same side meaning same side of the transversal, in this case to the left of the transversal. Interior because they are within the two parallel lines. Same side interior angles, or C angles, always add up to 180 degrees. Therefore, we say they are supplementary. And here is the other pair when we flip to the other side of the transversal. Supplementary angles. Same side exterior angles, like these two, are also supplementary. Outside the two parallel lines, on the same side of the transversal, we find a pair of angles that will always add up to 180 degrees. Same side exterior angles are always equal. Example 1. Find the measure of all the marked angles on this diagram. State the relationship of each answer to the original angle. So the original angle is marked as 62 degrees. And we would like to use that to solve the other three marked angles. We start with this one, and it is quite clear it is an opposite angle to the 62 degrees, so that is quite easily 62 degrees as well. Then we look across, and this one here forms an F setup with the original 62 degrees. F angles are always equal, so this angle is 62 degrees. Then we go to this one, and we do not have a direct relationship between this angle and the original 62 degrees, but 62 degrees and this one are both C angles, or same side interior angles, and we know they are always supplementary, so this angle will be 118 degrees. Reason: same side interior angles with this one. Example 2. Find the values of X, Y, and Z. For each answer, state your reason. This diagram here consists of two parallel lines, these ones, and two transversals. We should not get confused by the two transversals because we only need to deal with one at a time. So we will start by solving for X. And looking at X and looking at this 95 degrees, this is quite familiar as the F angles, and so F angles are always equal, and therefore X is equal to 95 degrees. To solve for Y, we need to find this angle first, and it's not difficult to see that it should be 95 degrees. Why? Because it is vertically opposite the X angle. Once we have these two angles, 95 degrees and 53 degrees, we now focus on this triangle. The sum of angles in any triangle is always 180 degrees. So to find Y, we do 180 minus 95 minus 53, and that gives us 32 degrees as the value for Y. Reason: sum of angles in a triangle is always 180 degrees. Finally, we look at Z. Z now is on the other transversal. We must look for a relationship between these 53 degrees and this Z because they are on the same transversal. We should be quick to note that they are on opposite sides of the transversal, but they are also external angles to the parallel lines. Alternate exterior angles are always equal. Therefore, Z is 53 degrees.
Watch the next video. Share with a friend. Subscribe and hit the notification bell icon. Thank you for watching.